Find the value of x and y in this diagram. So here is x and here is y from here to here. Okay, so we've got one triangle here, one triangle here. It's a good idea sometimes to draw them out separately. Now, why are they what we call similar triangles? Well, just putting all the numbers on, this distance here will be x, 10 plus y. This will be 18, 6 plus 12. For the smaller triangle, this is 4, this will be y, and this will be 6. The triangles are similar. Now, why are they similar? Well, this angle here is the same as this angle here because they're corresponding. These two lines are parallel. Likewise, this angle here, beta, is equal to this one here, beta, and therefore, and this one's the same in both. So applying those angles to these triangles, this is alpha, beta, theta, this is alpha, beta, theta. Because all the angles in each triangle, these two triangles are similar, i.e. this one here is an exact enlargement of this one. So, if that is true, we can say 18 over 6 is going to be equal to x over 4. Because the sides are in the same ratio. Multiplying by 4 here, we're going to get 18 times 4 over 6. 6 goes into 18 3 times. 3 times 4 is 12. So x is 12 centimetres. And in the second case, we've got 10 plus y over y is going to be equal to 18 over 6. So 10 plus y over y is equal to 18 over 6. 6 goes into 18 3 times. So if we now multiply by y, we're going to get 10 plus y is equal to 3y, 3 times y. And then taking y from both sides, we're going to get that 10 is equal to 2y. That gives that y will be equal to 5 centimetres. So x is 12 centimetres and y is 5 centimetres. This has been a video to show you how to use a triangle in a triangle and use similar triangles in order to calculate some unknown lengths. I hope you've understood, and I thank you very much for watching.